This video is going to be a continuation of Unit 1.2 about manipulating functions, and in this video we're going to look at composition of functions. To compose functions, where you have to look at what composition really means, if something is composed of something else, it means it's made of something else. So when I compose functions, I'm going to make a function out of another function. We're going to review some operations that we can do with functions first using the guided notes, the half sheet of paper that was passed out to you, and then we will move forward to see what composition looks like. So just to review operations with functions, we can do these four operations. We can add, subtract, multiply, and divide functions as equations or with the results as answers. And I want to just remind you of some of the notations that we can use to do these operations. So if I want to add two functions together, let's say I have function f and function g. If I want to add them, the notation looks like this: f plus g of x. The x in parentheses on the side doesn't mean I'm multiplying by x. There's no multiplication happening here. It just means that x is the variable that's going to be plugged in to each of my other equations, f of x and g of x. X is what's being plugged in. It's my input. And then the notation on the left says I'm going to be taking the function called f of x and adding it to the function called g of x. So what this really means is f of x plus g of x. But the notation on the left has slightly fewer symbols and is technically a little bit faster to write, and since we are mathematicians and we are lazy, we're going to try and use the simplest notation possible. So the notation on the left is more widely used to represent adding functions together. Similarly, we can show that we're going to subtract functions by writing the function names f minus g of x. And that means that we're going to take the function f of x and we're going to subtract the function g of x. So f minus g of x means I'm going to subtract my two functions. The pattern for multiplication and division is very similar with one small difference. With multiplication, I'm going to be careful with my notation here. So when I put my f and my g in parentheses here, I'm not going to use a dot or an x in order to represent my multiplication. I'm not going to use the x as the times symbol just because it can get very confusing with the x variable, which we're already used to, which is why we're used to using the dot for a product instead. But I'm also not going to use the dot here because this will get confusing if we use a dot, because it's going to look very similar to our composition notation. So instead of using a dot for multiplication, I'm going to use the computer's way of saying multiplying. So if you look at your computer's keyboard, if you want to type in multiplication on your computer, you use an asterisk. And that's the symbol we're going to use here to say multiply. It means the exact same thing as times with an x or with a dot. It's just a slightly different notation that's a little bit less confusing when we're about to compare it with our composition notation. So f times g of x. And that means that we're going to take f of x and we're going to multiply it by g of x. So it means the exact same thing as the dot for a product, but the notation inside the parentheses will be easier if we consider it this way. So f times g of x. And of course our last operation is going to be division. I'm going to write it in my parentheses here with again, the symbol that your computer uses, which is that slash f divided by g of x. And that just means I take the function f of x and I divide it by the function g of x. There we go. So these are the operations that we can do with functions. I want to get some practice with these. So on a separate piece of paper in your notes, which you can title 1.2 Composition of Functions, just like our heading on the previous slide, we are going to go ahead and look at these same operations with functions. So make sure that you write down this as your heading. So we have 1.2 Composition of Functions, and then you can label this section Operations with Functions. Go ahead and write down these equations. Our first set of examples is going to be based on these two functions. So if f of x is 4x plus 7, and g of x is negative x plus 2. Make sure you write down these two equations. We are going to go ahead and do some operations with these. So let's try this first example, A, which is going to be f plus g of x. Now remember, when it says f plus g of x, that means the same thing as taking f of x and adding g of x. So in order to do this operation, I'm going to take the function f of x, which is right here, 4x plus 7, and I'm going to add to it the function g of x, which is this function right here, negative x plus 2. I'm going to add these equations together. Now I have to take this whole equation and add this whole equation. Because we're adding, the parentheses aren't really necessary, but it is a good habit to use them just in case I have to do anything with subtraction or distributing any other values. I can make sure to do that first. But in this case, because everything's positive and I have nothing to distribute, I don't technically need the parentheses there. So I can go ahead to my next step, which involves combining like terms. I have a 4x over here, and I'm subtracting an x over here. So 4x minus x is just 3x. And then I have this plus 7, and I'm adding this plus 2, which gives me plus 9. So my final answer for f plus g of x is a brand new equation where I took the function f of x and I added in the function g of x. So because I had an x left here and I didn't plug in a value, my result is an equation with x still in it. It just takes the f of x equation and adds in the g of x one. Let's go ahead and take a look at another example. This one is f times g of x. I'm going to use these same functions, and again that means that I'm going to be taking f of x and I'm going to be multiplying it by g of x. So let's go ahead and find our f of x equation. We're going to multiply it by our g of x equation. So f of x is still this equation on the left, 4x plus 7, and g of x is the equation on the right, which is negative x plus 2. Now in order to multiply these together, I'm going to have to use the FOIL technique that we haven't seen since Algebra 1. We didn't really get to review it very much. But foiling is where we multiply the first, outside, inside, and last terms together. And then we can combine like terms to simplify. So I'm going to start with the first terms and multiply those together. 4x times negative x. 4 times the negative gives me negative 4. And x times x gives me x squared. So we can multiply the coefficients and multiply the variables. Next we move to the outside terms. So 4x is on the outside of the left, 2 is on the outside of the right. Multiply those together. 4x times 2 is 8x, and it'll be positive, so plus 8x. We move to the inside terms. 7 is the inside on the left, negative x is the inside on the right. 7 times negative x, the 7 and negative will multiply to negative 7. And the x has nothing to multiply it with, so it will stay the same. And then I will multiply the last terms together. The last on the left is 7, the last on the right is 2. Multiply those together, I get a positive 14. All I have to do to finish this problem is combine my like terms right here in the middle, and I will have simplified, and this equation will be done. So the negative 4x squared will stay the same. But I can do positive 8x minus 7x. I have 8 x's and I'm subtracting 7 of them. I'll only have 1 left and it will be positive. And then I can bring down the plus 14 that also hasn't changed. So this time I had to take my f of x function and multiply it by g of x. And I got f times g of x is this quadratic right here, negative 4x squared plus x plus 14. So I multiplied the two equations together to get my result. Now I can also do operations with functions if I have values to use. So let's look at what operations look like with values. So what I mean by with values is that I'm going to take an x value and I'm going to plug it into the equation. Now my advice for you, oh goodness, that got very yellow very fast. My advice to you, and I would recommend that you write this down, is if you have numbers to plug in your numbers first. Always. So anytime an equation gives you values for your variables, always plug them in first. It's much easier to do operations and simplifications and math with numbers than with a bunch of letters. So always plug in numbers first. So in this problem, I have f plus g of 2. That of 2 has taken the place of x. So this means f of 2 plus g of 2. So my first job is going to be to plug in 2 to my function f of x and to my function g of x and figure out what those values are before I do any math. So I'm going to go ahead and do that off to the side here. So f of 2 means I have to take my f of x equation, which was 4 times x plus 7, same equation from before, and I'm going to plug in the number 2 here and see what I get. So 4 times 2 is 8. If I add 7, I get the number 15. So f of 2 is 15. We're going to store that away. We're going to use that. Up next, I'm going to find g of 2. So I'm going to take the number 2 and plug it into my g of x equation, which is negative x plus 2. And I have to plug in the number 2. Well, negative 2 plus 2 is just 0. So g of 2 is actually the number 0. So instead of using the phrase f of 2, I'm going to use the number 15. And instead of using the phrase g of 2, I'm going to use the number 0. So when it comes time to plug in my equation up here, f of 2 plus g of 2, I'm going to use f of 2 is 15, and I'm going to use g of 2 is 0. And then I just have to add them together. And that's it. 15 plus 0 is 15. Now notice, when my operation had a number inside of it, my answer, f plus g of 2, when my operation had a number inside of it, my answer is also a number. So when my operation has a variable inside of it, my answer will have variables in it. It'll be an equation. But when my operation has numbers inside, my answer will be a number. Let's try one last one. F times g of 2. Now this one, we're not going to go through this whole rigmarole again. This means f of 2 times g of 2. And the very first thing I should do is plug in my variables, and I already did right here. There's f of 2, it's 15. Here's g of 2, it's 0. So in order to solve this problem, all I have to do is multiply these together, and I'm done. F of 2 is 15, g of 2 is 0, f of 2 times g of 2 is 0. Anything times 0 is 0. We just found our answer much, much faster because we had done the work of plugging it in first. So f times g of 2 is 0. So when you do operations with functions, you just do whatever the operation is with each individual function. If you have values, make sure you plug them in first. Now let's take a look at what composition of functions entails. So we're going to go back to our guided notes page, and we're going to write down some notation for composition of functions. So we have a US notation and we have Cambridge notation, because this is technically a Cambridge course, which means we want to learn how the people in England are writing these math problems in case you go on to ACE Math in the future. Your test questions are going to be phrased in British ways, including British notation for some stuff like this. So I want to show you the US notation and the British notation so that you can recognize either one. So composition of functions means I'm going to plug one equation into another equation. So the first way we're going to try that, again with functions f and g, is I'm going to plug f of g of x. And I know it's not very clear here. Let me fix this guy. Sorry, my stylus makes this difficult. This is of. It's like a teeny O. It kind of looks like the word fog, but the O is written really small. Now you can see why I didn't want to use a dot for multiplication, because it looks a lot like this little O, and this little O means f of g of x. Now the Cambridge notation for that is f of g of x. The Cambridge notation doesn't have the first set of parentheses, it doesn't have the little O, it just puts f and g side by side. And what this notation means, just like I say g of x, and that means I plug x into g, when I say f of g of x, it means I take g of x and I plug it into f. This is f of the phrase g of x. So g of x is going to live inside the function x. So here I can say I'm going to plug g of x into f of x. So I'm going to plug an entire equation into another equation. Now we can also do this in the opposite direction. I can go backward and put the g first. So let's take a look at what that would look like. In my US notation, it would be written g of f of x, right? That's a little o. In Cambridge notation, the g just gets written first, g of f of x. And that means that f of x is going to be plugged into g. So g is on the outside and f of x is being plugged in inside. So plug f of x into g of x. So the important thing that I want to signify here is I need to work from the inside out. I need to figure out what's going inside and what it's going into, all right? And we're going to deal with this the same way we dealt with those operations with values. If I gave you a value, you should use the value first. And the value is the inside term. It's what's being plugged in. So we're going to work from the inside out. Let's write that down here. Work from the inside. And I want to go ahead and show you again, the inside number is going to be the number in the function, which is to the right of the function I'm plugging it into. So I want to work from the right to the left. I want to work from the inside to the outside. So the inside is the right, and then I'm working my way out, which is to the left. So this kind of goes against everything we know about math so far, because everything we've learned about math mirrors everything we know about reading, which is that we should always work from left to right. But when I'm doing composition, when I'm plugging something in, I'm looking to the right of my function first so that I can kind of work my way out. I want to start on the inside, figure out what that is, and then work my way toward the outside. So let's go ahead and take a look at what this composition is going to look like in our notes. So right after your work in your notebook for operations with functions, let's go ahead and look at composition of functions. We'll try out some examples here. This time, our examples are going to use these equations here. So f of x is x minus 5, g of x is x squared plus 2, and I want us to find some values here. So the very first problem I'm going to do, which we're going to call example A for this section, is I want to find g of f of 1. G of f of 1. So let's go ahead and see what that means. G of, and I plug something into g, that's this guy here. What I'm going to plug into g is f, f of, and then what I'm plugging into f is this number right here, the number 1. G of f of 1. My job is to start from the inside and work my way out. The very most inside thing is the number 1. So this is going to be the very first step that I do for this problem. I need to work with the number 1 first, and the number 1 has been plugged into f of x. So I'm going to start with my f of x function, which is this one right here, f of, and I'm going to plug in the number 1. So my f of x function is x minus 5, and I'm going to go ahead and take that x, and I'm going to plug in the number 1 instead. X minus 5 means I'm plugging in 1 and subtracting 5. And that'll help me figure out the inside value. So if I do 1 minus 5, I get the number -4, and that is f of 1. Now that has to get plugged into g of x. So whatever result I get from f of 1, that gets plugged into g of x, which means now I'm finding g of -4. Now that I'm finding g of -4, I'm going to take my g of x equation, which is this one right here, which has x being squared, and then I'm adding 2. So x being squared, and then adding 2. I'm going to go ahead and take the x value I just got from f, that -4, and plug it in right here. -4. That's the value I got out of my f equation. I plug that into my outside 1g. Let's go ahead and solve that. So this time, -4 squared, that's -4 times -4, that's 16. If I add 2, I get the number 18, and 18 is my final answer for this problem. So g of f of 1 is the number 18. Again, since I started with a number being plugged in, my answer will also be a number. I just have to start by plugging in the inside number and work my way out. Let's go ahead and try this second example. It's going to be very similar. This is going to be f of g of, is that what I wanted to do? This is supposed to be the number 1. Sorry, I had a typo. Can I fix that? I made a boo-boo. We're going to do f of g of 1, not f of g of x. Oops. Nope. It's being the worst. Sorry. There we go. All right, fixed it. Everything's fine. So we're going to do f of g of 1. So again, this time I'm going to do my inside first. So again, my innermost thing is 1. It is inside g, which is inside f. So if I rewrite this function, this time I have f of, inside f is g, so f of g of 1. So the 1 is in the very center. That's still where I start, and I'm going to plug it into what it's most directly involving, which is that g. So I need to find g of 1. That's my inside equation. I need to find g of 1 first. So same g equation, which was x squared plus 2. This time I'm going to plug 1 in here. So g of 1 first. So let's see what that gives us. 1 squared is 1 plus 2. I get the number 3 for g of 1. That's my inside answer. I need to plug that into f. So I need to take the number 3 and plug it into the function f. So I need to find f of 3. Whatever my inside gave me, that's the number I plug into my outside function. So I'm going to find f of 3, and the f equation takes my number and subtracts the number 5, x minus 5. So my x value that I'm plugging in here is the number 3. I need to subtract 5 from that. 3 minus 5 is negative 2. And that tells me my answer for the whole function. F of g of 1 is the number negative 2. So I found g of 1 first, and then I plugged that into f, and then I got my final answer. I have 3 questions for you to try. I would like you to try them in your notes using these 3 functions right here. F of x is 9 minus x, g of x is x squared plus x, and h of x is x minus 2. I want you to find me f of g of 2, I want you to find me g of h of negative 2, and I want you to find me h of g of f of 1, which is a little bit of a challenge. I want you to work on these and show the answers that you've gotten so that they can check you off. And then once you're finished with all 3 of these problems and have the right answers, you can work on your Math Excel assignment. So just to clarify here, the first problem is f of g of 2. That means you have to do f of g of and the number 2. Okay, so work from the inside out. For the second one, you're going to have to start with g right here. So g of, inside that you're going to have to put h, which is h of, and then you're going to have to plug in the x value, negative 2. So make sure you work from the inside out. Plug in your negative 2 first. Last but not least, this is a really fun one. You have to start with the h function on the very outside, h of. Inside that, you're going to go to the g of function, g of. Inside that, you're going to go to the f function, f of. And inside that very, very center, you're going to plug in the number 1. So again, remember, work your way out. Start with the 1 inside f. Take that answer, plug it into g. Take that answer, plug it into h. And good luck.